Picture is worth 1,000 words. We say this when capturing memories and photographs, or we hear it from instructors telling us to stop reading off slides during a lightning talk. But a picture is worth 1,000 words because an image is simply a grid of points we call pixels. These pixels contain the color information that makes up the images. For our phone cameras, each pixel has three values for red, green, and blue. But images can have pixels that range from one value to hundreds. And by analyzing the patterns in these pixels, we can figure out what the image shows. And that's where the thousands of words comes from. But what if a picture is worth more than 1,000 words? What if a picture is worth hours of labor or more money in a grower's pocket? Take a look at this image. It's of a tomato field with fruits nearly ready to harvest. But we notice a problem, early blight. It's a fungal disease that's present. This is where my research comes in. I explore how we can use images to identify crop diseases in field earlier. Right now, disease scouting is often done by teams walking through fields looking for symptoms on leaves and fruits. This takes time, it can be subjective, and it risks missing things. And if the disease spreads before it's noticed, it can hurt yields and the growers' incomes. So by combining imaging with artificial intelligence, we can teach computers to spot patterns quickly. We can learn color changes or changes in leaf shape to determine how sick the plants are. And we don't just use regular images. In one project, I use hyperspectral imagery, where pixels contain much more detail, far beyond what our eyes can see or our phone cameras can see. This allows us to detect tiny changes in the plant's health before the symptoms become visible. In another project, I worked with 3D multispectral images. They not only capture color, but also the shape and structure of each plant from every angle. And we compare these with standard phone images to build smarter models that improve disease detection even with simple tools. And the goal is to then use ground robots or drones to move through a field to provide insights on areas of disease presence and its severity, cutting down on hours of manual scouting. Catching diseases earlier not only means more tomatoes, also allows for more targeted application of fungicides for reduction in chemical usage, again, saving money for our growers. So yes, a picture is worth much more than 1,000 words. This image might just show a tomato field. With the right tools, it also shows what's wrong, where it's happening, and how bad it is. And when every pixel tells a story, it means we can act faster, grow more, and spray less. Thank you.